Okie dokie. An object is launched from a height of 80 feet with an initial velocity of 131 feet per second. Okay. And after X seconds, its height is given by this. Why do I need to know the initial velocity? I'm not sure. Anywho, maybe that will become apparent later. So this equation here is giving me the height of this object. I'm seeing the minus, which I know means a concave down shape, right? So I'm imagining this, right? I've got, like I'm on top of a cliff or something. The cliff is 80 meters, not meters, feet. 80 feet, apologies, I don't have a proper pen, high, and we launch this object like this. Right, and you can see the path of the object is a parabola, right? It says solve for the number of seconds x after which the object is 30 feet above the ground. Oh, okay. So somewhere down here, this can be our ground. Ground. Wow. Now, what height is the ground? 0, right? So h will have to equal 0 at this point. You can imagine this is on a Cartesian plane, right? Maybe this can be 30 here, right? And if it was to come all the way down to the ground, the height would be 0. H would equal 0 at the ground, right? Okay. Solve for the number of seconds x after which the object is 30 feet above the ground. All right. So I'm going to delete all that stuff. Clear. I'd recommend drawing a little diagram for yourself, but you can draw it a lot neater than me. Okay, so I want to know where the height is 30. That's why I'm writing h equals 30 here, plus 80. That can be step 1. No, I wasn't happy with that. Oh, well, whatever. I'm going to keep going. H equals 50. So once I tidy this up, that 30, I'm going to minus 30 from both sides. Oh, I forgot the x. That's what it was. Is it happy now? Yeah, that's better. So I'm going to minus 30 from both sides, right, to make that 50. And then I've got my 0. And then I'm all ready to go with quadratic formula, right? We could put the, normally we'd have the equal 0 on the right. So let's do that. Okay. Now the A term here is minus 16. The B term is 131. And the C term is 50. All right. So x equals, we'll find out if it lets me do minus 131.
1 or 2 croissants?
Just one.
You're not hungry, you're on diet.
Yep. Sorry about that. Plus minus, yep. Good work, math space. Square root, squirt. B squared, 131 squared. We've got a number for squaring? Yeah, we do, good. You know what I mean. Minus 4 times the A term, minus 16, times the C term, which is a 50. And then the reason I did that in brackets is because I need to divide the entire thing by minus 32, right? Because Now, we can probably get rid of the brackets. Yeah, that's fine. But I just wanted to make sure that this was all in the numerator here. And then I've got my denominator, which is a 2a, and that's 2 minus 16 is giving me a minus 32, right? So what I really need to know is what's this 131 squared minus all of this stuff, right? Which will actually be positive because you get minus 4 times minus 16 and times a 50. So if I can remember those numbers. Oh, I also need, I've got no idea what 131 squared is either. So let's get a calculator up. All right. What I'd like to know is what's the 131 squared minus 4 times, I'll double check our numbers, A and C, minus 16 times 50, okay? And I get 20,361. Now, I don't think that's going to square root nicely. We could try. Yeah, not really. All right. So I think in the next line of work, 2361, let's write that. 20, so I'm just sorting out this bit in the middle here. It's called the discriminant, 2361. This part of the quadratic formula in the square root. Okay. Now it wants answers to one decimal place. Okay, now what's interesting is that one of these answers will be a negative number because that square root there, well, you know, we'll just go to the calculator and I'll show you. Minus 131 plus, all right, minus 131 plus, now this whole thing has to be divided by minus 32. Let's start that again. Plus the square root of this number, which I've just worked out. We'll keep it like that. All divided by minus 32. I'll just check the numbers. Is that a 131 and that's a 32? Yeah, minus 131 minus 32. All right. So that's where I've got a plus, and I get this number here. What happens if I use a minus? So go back, make this a minus. All right. So I got one negative answer and I got one positive answer. Are they both right? And no, they're not. Only the positive number, 8.6 it's going to be. Because I can see it here. My x's are representing time in seconds, right? Does it make sense to think about negative 0.36 or whatever it was seconds? And the answer is no, it doesn't. So the formula does give me two values for x, and if I put those values into this quadratic, the quadratic will spit out 0. But I only care about the positive answer because the positive answer is representing time, and time cannot be negative, right? So that's why the answer there is 8.6. Now, is that all you had to do? Seemed like a pretty easy, pretty straightforward question, but it was definitely a calculator question, and it was definitely a question that needed quadratic formula, all right? Hopefully now you are convinced that there is a use for the quadratic formula because you sometimes are dealing with large numbers and you are sometimes dealing with numbers that cannot easily be factorized from your quadratic. Okay.